Hi guys, AnyPixel here, and in this video what we're going to do is we're going to walk through building out the base of the Firewatch Tower. Alright, so on this first part, we're just going to focus on the stairs and the base here. We're going to walk through how to make sure that we can add, as many floors as we want, and the stairs basically spiral around it. Alright, we're going to go through things like how to set up all the UVs for it, how to set up the HDA parameters for this stuff, so we can tweak these things. Like you see here, you can change the heights of all these things. We're going to go through and just get kind of this basic tower setup going in this first video. It's kind of a long video for a YouTube video, but I'm trying to make sure that I show you guys every step of the way. I don't want to skip anything because I've had individuals ask about, either going too slow or too fast, and so I'm trying to be as thorough as possible here. You also have the option of, changing which side the stairs are on here. This is Houdini Engine version 2. I need to note that it is still beta, and so there are bugs with it, but it is getting there, and it's starting to get nice and solid, so really cool stuff. It's a lot faster, a lot better, so let's get started with building this tower. Alright, so let's get started. I'm going to start by creating a subnetwork because this particular model is going to be composed of multiple objects, and so in order to do that with the Houdini engine inside of Houdini itself, we need to put down a subnetwork. So I'm going to call this guy the Firewatch Tower, and then hit enter to dive inside, or you can double click on it as well. I'm going to select all these guys and hit Shift L just to kind of organize them. You don't have to. And then I'm going to drop down a geo node, and I'm going to create two of these guys, and this one is going to be called the tower. So then I'm just going to hold down Alt, left click, and drag to create a copy of that. And I'm going to call this the house. And so we're just going to keep just these two guys for now. We're just going to focus on the tower and the house for now. And so inside of our tower, to get this set up, it's actually pretty simple. I'm going to drop down a grid here and hit F on the keyboard just to zoom out. I'm going to set the size to 4 and 4 here, and then the rows and columns to 2 and 2, because I want just a clean geometry. I want to use the geometry that's created here, all these points, to build up the legs and the different floors, if you will, for the tower itself. And so now what I did for the Firewatch Tower is I dropped down a couple of copy nodes. So the first one that I created was a copy transform node here, and this one's going to be done for the legs itself. So I'm going to hit Shift S to create the different wire look there, and I'm actually just going to transform this up around, I'd say, 2 meters, like so. And let's create 4 copies like that. So now we have these grids copied 4 times at a interval of 2 meters per grid there. And then what I also want to do is I want to scale it down as it gets a little bit higher, right? So as each copy is created, I want to scale it down a little bit. So you can use the scale, and basically this is a percentage based on the current copy number. So you could scale it like that, right? And we'll go and promote all these values so you can control it from the HDA itself. For now, I just want to get the system all set up. All right, so with that done, we can now use an add node and extract some curves out of that data. So we drop down an add node and then just say delete geometry but keep the points. I'm going to switch over to the polygon tab here, go to by group, and what I'm looking for is the skip every nth point. So I'm going to skip every nth point. And then what we need to do is we need to set the correct n value. Now this n value is going to be the number of points in this grid, right? So there's a couple ways you could do this. So let me just demonstrate here really quick. So if I type in 4, right, I get 4 lines, and that's just because there's 4 points on our grid over here, right? And so we can actually use an expression for this. So we can say n points like so, and we can get that information by typing in a string here, and that string wants a path to a node, and in this case that node is this grid 1, right? So all we need to do is say // grid 1. And there you go. So now we've got those 4 lines. So now, if you wanted to make a tower that has more than a few legs here, you could, right? So you can go and make a couple extra legs if you wanted. I'm not really going to do that. I'm trying to copy the Firewatch Tower here. Let's actually scale this in just a little bit, or out a little bit more. Yeah, something like that. the pitch isn't really that drastic on this. Alright, so now we've got those legs, and now what we do is we do some sort of like sweep, right? But we're going to be doing this quite often, and so I want to make an HDA for that. So we'll get to that here in just a second. Let me actually go and just set this to our square tube for now. So you can see that we actually have those particular legs in there. And I'm going to set the columns to just 1 for now. And the width actually looks pretty good so far. We can also go into the construction over here and set our curve normal to something like the z-axis. Yeah, just to get them all squared up. I don't really want them tweaked like that on the rotation. Cool, so now we've got our legs all set up. So at this point, what I want to do is I also want to build up the cross beams, basically, for these guys. And so I'm going to make a reference copy of this, all right, because we need to do something special for that particular system. So I'm going to right-click on my copy node here, and we are going to create a reference copy. And you'll notice what that does is it hooks up every single parameter so that it matches this one. All right, because I want to maintain the scale and the total number. I just want to change one parameter on this copy node here, and that's the rotate. So I'm going to hold down Control and Shift and then just left click on the Y rotation here and type in 90 degrees. So basically what we're doing is for each copy, we're actually spinning the grid 90 degrees. And the reason why I want to do that is because I want to get the point numbers so that they're rotated around. So basically, when I use an add node, we'll get a line that is being drawn between all of the corresponding points, but it's spinning as it goes up each copy, right? So just to prove this here, we are going to drop down another add node, right, to create curves. So I'm going to drop down an add node here. We're going to delete our geometry, and then we're going to say by group. And in this case, again, if I were to use the skip every nth point this time around and put in 4, we're going to get a spiraling set of curves. And that's exactly what we're looking for. And so we can just come over to this add node over here and copy that expression. So that way we are all procedural. Beautiful. Awesome. And so with that done, we can also just copy our sweep node over here and do that. And now we've got our cross beams, basically. We're going to have to do a little bit more work on that. So let's actually set the y-axis here. Let's find an axis that would actually like to work. We might actually have to create our own normals for this, which is fine. All right, and so all we need to do is just drop down a wrangle node here. All right, and call this curveders. That's what I usually call it. And we also need a polyframe node above that to create our flow normals. So let's just turn off the normal name there and then type in capital N for the tangent name, and that will give us our normals that follow the curve up here, which is nice. All right, and let's actually just plug that in. Sometimes that actually does just do the trick, but in this case we need to provide the up axis. So if we say v at up is equal to 0, 1, 0, and take a look at our sweep node, you can see that they are trying to face upwards. It's just that they're having a little bit of time, you know, trying to go around the turn there, around the corners. And so one thing we can do is put in a convert line to break up each of those segments into its own individual curve, like so. We don't need this guy here. Yeah, and there we go. And you notice we're still getting the twisting. I really just want to leave this on curve normal. We're still getting the twisting around there. And so that usually means the convert line doesn't always create, I mean, it will create individual primitives. Let me actually plop that back down and explain this a little bit better. So you notice with the add node, we have just a single primitive for each curve here. But when I do a convert line, I get a primitive per segment. But if I were to look at my point numbers, we have a single point for each one. So they're not actually broken out into individual segments, right? So let's actually do this a different way. I need to drop down a carve node for this. And we want to cut these basically at every single breakpoint. And so for this, I'm going to just put this to 0 and 1, like so. And we're going to go to breakpoints, and we're going to cut at all internal U breakpoints, excuse me. And so now you'll notice that the point number is actually, we have 2 points for each one of these corners here. And so if I were to plug this in, do the up vector, and then do the sweep here, you'll notice that we now get these guys pointing straight up, or oriented as they should be. All right, so we need to actually break them into individual curves like so. The other thing I want to do too, we also need to basically reverse. So if we go to our surface here, reverse the cross section so that we get proper normal, so they're not inverted, like so. I also want to basically control the inset here, and so I'm going to drop down another carve node. So on a per curve basis here now, I want these guys to, I want to control the inset on both sides there. And so I turn on the first U and the second U, and then I copy the first U, paste that into the second U like so, and then I just do a 1 minus to get the remainder value. So now if I do any sort of value for this first U, I get the same exact offset on the end of it, like so. Let's just kind of pull it away. There you go. And so there, we now have those guys. And like I said before, we really want, because we're going to be doing this sweep stuff quite often, and I also want to take advantage of the UV construction from the sweep node, and so we really should create a HDA to do this for us without us having to plop down the sweep node and getting all the settings set each time. So that's where an HDA really comes into play. It's very handy. Let's get rid of this convert line node as well. And so with that, I'd say now is a perfect time to merge these two guys together and then focus on creating that HDA. All right, so now we've got this particular setup here. And if you wanted to create, you know, a crossbeam for the other side, it's actually pretty simple here. We can just take, right after this carve node here, if we just do a transform and then basically invert its scale, let's say on the X, you could do it on the Z as well. You'll notice now we have perfect crossing beams like so. So all we really need to do then is just merge these guys back together like that, and there you go. So now we've got cross beams. All right, and you could do some tricks here. I might actually show you guys how to do a little trick to get the brace that would hold these two planks together basically. It's not that difficult, but that is, you know, the general technique to get that all set up. So let's move on and create our HDA that will basically build wood planks for us, and so we're not having to constantly drop down sweep nodes. All right, so let's move on to that. Let's now focus on getting our HDA all created, or a couple of HDAs here. So the first thing I want to do, I do want to turn the Firewatch Tower into an HDA here. So I'm just going to right click on it, and I'm going to set this up with my namespace for IndiePixel there, and a version number, and we'll just work on the name of the actual HDA here. This is the actual name that you see on the node itself, and I'm just going to save this to my HDA library for this particular project. I'm going to call this actually 2.0, like so. Let's actually cancel this out here and fix this up here, because I have my other version. There we go. So then let's go and save this into this folder here. You can save it wherever you'd like. Perfect. So with that, a couple things we can actually get set up right off the bat here are things like the height, right? So let's go to this particular copy and transform node that's controlling everything. Remember, this is just a reference copy. All right, so it'll pick up any changes that happen in this particular node here. Let's do the height of the tower here. And let's go and hide these guys. We don't need these anymore. So let's just highlight this, and then you can just left click and drag it into there. And we'll call this the tower height. And then for the label, we'll do the same. And let's set up our ranges. So I want to say that, you know, 3 feet is the minimum, and the max, let's do 4 meters. And we'll leave the default at 2, like so. Very cool. Hit apply, and let's also let's promote the size of the grid so we can change the overall size. So I'm actually just going to highlight the X size here, and we'll put it down here. We'll call this the base size X. We'll call this base size for the label itself. And again, we want to make sure that we clamp this so we can't create an inverted grid there. We'll say the max is, I don't know, 10 for now. I'll leave it unlocked though for the max so it can be changed, and the default will be 4. Cool, so I'm just going to leave it at that for now for the tower. So now if we were to jump up all the way and out using the U key on the keyboard, I can go and change the size of my tower and the base size of everything. So everything's working pretty good here. It looks like I am getting a little bit of a issue right there, so that's probably coming from the inverted transform over there. So we'll take care of that here in a little bit. So what I'm going to do now is I'm going to jump inside into my tower here, and what I need to focus on is creating the HDA that builds our wood planks for us. All right, cool. So let's drop down a subnet. So this is going to be what is referred to as a SOP level HDA. So if you were to create an HDA up here, like we did for this Firewatch Tower HDA, this is an object level HDA because it contains multiple objects. We're creating now a SOP level HDA because it's more of a utility that you put inside of your HDAs. All right, so I'm just going to call this IP wood plank. There we go. And let's go and just create a digital asset out of that real quick here. And I'll call this also version 2, like so. And we'll just capitalize these guys. Now what I want to do is I want to save it into that same library. So I'm not going to save it as its own HDA. I'm going to actually make it so that it goes with this Firewatch Tower HDA. So I'm going to save it into this library. I'm going to hit accept and hit accept. And there we go. So now we have 2 HDAs basically in that one HDA. The HDAs are just what used to be referred to as operator type libraries. All right, so this is just a library of HDAs. Cool. So let's hook up the curve here, and I'm going to double click it to jump inside. And our first input here, I'm actually going to just push this off to the side here. So our first input here is the curve itself. So let's just give ourselves a little bit of information. I'm going to call this curve in, like so, and hook it into the output node that was created for us. There we go. And now I'm going to do a resample, right? So I want to let users basically resample this particular curve, and you'll notice that will go and resample it. So what I'm going to do is actually switch this over to the maximum segments option, and also do the resample by polygon edge up here, just so that it resamples based on each segment of a curve. All right, and then the reason why I want to do this is because I want to allow users to change the resolution to a very specific number. This one's based off of the overall length. All right, I just want to be able to decide what number of points I want. So I'm just going to leave this on a default of 2, like so. Looks pretty good. And then basically I am going to then drop down a switch node and a polyframe node, because I want to give users of this particular HDA the option to add normals to it. So we're just going to set up our flow normal technique here. So it's capital N for that. And this switch then will be driven by the user. So we'll say normal switch here. So they have the option to add normals to the curve or not, right? Because I'm just, at this point in my development of my HDAs and my systems, I really don't want to have to plop down that polyframe node all the time. Cool. All right. So with that done, we now have, a way to resample our curve. So let's promote some of those parameters first before we get too far here. And what I'm going to do for this guy is I'm just going to drag out a folder here. I'm going to call this the resample, like so. And I'm just going to make it a simple block here. Very cool. And you can also develop these things in tandem while you're working on your graphs. If you come up here to where we have our parameter view, I'm going to split this left and right like so. And then I'm actually going to make sure I have this node selected. I'm just going to pin it. All right, so when you pin it, basically if I were to dive inside, only this parameter view is going to update, but this is going to constantly show me what my HDA parameters are like. So I can work on my graph and tweak parameters on the HDA itself. So let's promote our 2 things here. So I have my segments. So there we go. So we want segments. That's actually a good name for it. Yep, I think the defaults are fine. So we'll just leave it at that for now. And then we also want to promote our switch here. So I'm just going to drag and drop this guy out here, and let's put that into another simple folder as well. and we'll call this normals. Let's capitalize that to be official. There we go. And I'm going to drag and drop that parameter into that normal folder there. And then what I want to do is switch this over to a toggle type. So we just have a toggle. It says basically, do I want to add normals or not? So I'm going to call this the normal toggle. And we'll say add normals with a question mark. Very cool. And I'll leave the default at 0. So now if I hit apply, you can see now in our pinned parameter view up here, I've got this option to switch between adding normals or not. And you know, I think I'm going to leave that on as the default. So I'm just going to set this as 1 for the default there. And then we have control over our point numbers, or the amount of points we have on our curves over here. So very cool. All right, so now that we've got that done, I'm going to hit apply and accept over here. And the next thing we need to focus on is actually turning it into some piece of geometry. So what I want to do now is I'm going to add a grid. Most of these wood planks are basically the same particular shape, right? Some sort of, you know, 2x4 or 4x4 kind of thing. And so let's just get this set up so it's a unit grid. So I'm going to set the grid size to 1 and 1, and then 2 and 2 for rows and columns. All right, so now I've got a unit size grid here. And I want to set this guy up onto the XY plane, like so. And so our goal here is to basically feed this into a sweep node. So if I were to drop down a sweep node right here and feed in the grid to the second input, all right, so the second input is the cross section. The first input is the backbone or the main path that you're trying to sweep along. All right, and you'll notice that what happens is now we get that particular grid. So I want users to be able to adjust, you know, this size to whatever type of wood plank they're making. If they're making like a 4x4, or maybe they're making just some, you know, actual plank that's like a 2x6 or something like that. All right, so I think the default of 0.5 and 0.5 is going to be good here. And on our sweep node itself, let's go to the construction tab and let's just set it to a particular axis over here. And actually, I think I'm going to leave it on curve normal for now. You know, one thing we could do is actually promote that. So let's open up our HDA type properties. So you can do that from the little breadcrumbs up here. So if you just right click and say type properties. I am going to create another simple folder here. Let's set this to simple. And we'll set this guy to simple as well. And this one's going to be called the sweep. So I just want to promote a bunch of parameters that we tend to use quite often. So I'm going to put that right up there, and then up here I am going to, let's see, which ones do I want to actually promote here? Well, we could always do the scale on curve. I'm not really sure just yet if I want to do those ones just yet. So we definitely do want to do UVs and stuff like that. So let's make, well, actually let's just put all this into the, so let's sweep that. I don't actually want to set this to on by default, so that way I get my UVs. So I'm going to move this out to the side here. I'm going to hit 5 on the keyboard. You can see now I'm generating UVs for it, and I want to do that for everything. So I do want to do length weighted, but I don't want to normalize it, and I also don't want to snap. I just want this to be the actual size in UV space as it is in 3D space. Cool, so now we got all that stuff set up. Yeah, I think that's going to be good. I'm going to hit apply. Cool, so now we have control over those sweep parameters that we tend to use quite often. All right, so now I can switch it based off of whatever I need, and I can also turn this on if I want to generate UVs or not. We're also going to need the size of that grid as well, so let's just pull this out into the sweep here. All right, so now I have control over the size of my piece of wood here, which is great. So now I can change it as I need. Cool. So this one I'm going to leave at 0.5 and 0.5 for now. The other thing that I wanted to do was add in a bevel operation for this guy. So let's do that as well. So I'm going to come over here. I'm going to drop down a polybevel node. And we are going to just bevel the actual corners. Now you can do it on the actual, or after the sweep node if you want. In this case, I am going to do it on this piece. And the reason why I want to do that is because then it'll be taken into account with the UVs. And if we were to do it after the sweep, we might have to do some UV cleanup. So I'm going to do it at this level. All right, so now we've got this guy. I'm going to set it to points, right? Because I want to bevel the points here. And then I'm just going to add a starting value of like 0.05 for this. I'm really doing that just to make it so that it catches some specular. All right, so let's make another folder over here, and we're going to call this beveling. And I'm going to set it to simple. And we are going to drag and drop the bevel distance into that beveling folder. And I think that's pretty much all we're going to need. Well, let's, just in case you do want to put in some different types of fillet size. There you go. All right, and then finally let's make it so the user can turn off the beveling if they don't want it. You always want to try to give as many options as possible without getting too crazy. So we'll call this a bevel switch, like so. And we'll feed that guy into there, and then we'll just make sure everything's working. Let's take a look, and let's promote the bevel switch. So I'm going to drag and drop this guy up here, and we will call this our bevel switch for the internal name, and we'll say use bevel, question mark. And again, I'm going to turn this into a toggle, so it's just a button basically. Cool, so now let's feed that into the final output here. Beautiful. So now we have a nice little utility to allow us to do all those operations without having to drop down those nodes anymore, because that can get quite annoying. All right, and we have perfect UVs. Beautiful. All right, so with that, let's do the last thing, very important. Always right click on it, say save node type, and then let's do match current version, and then let's get rid of this sweep node. All right, and then let's just do a alt click and drag. So left click and drag here while holding the alt key. And right down here where we're doing the sweep, let's just get rid of this and plug in our utility. Look at that. So now we have control. Let's actually unpin this and get rid of this tab here. So now I have control over wood planks. So I can make a bunch of wood planks now that just have UVs, and I don't have to worry about dropping down all those nodes or remembering all those nodes constantly. Even though it is good practice to remember that stuff, this is what HDAs are really meant for. Very nice. Okay, so I'm going to get rid of this sweep node here. Looks pretty good. I'll probably tweak it a little bit more off camera here, but that is looking pretty good. It's a little fat for now. Let me actually make this a little bit smaller here. Yeah. All right, so let's actually, those guys are pretty good. Let's make it a little bit smaller here. Yeah, we also need the cross beams, but I'm going to close that out there, and that is making the wood plank. So now we have a little utility we can just use constantly. And really, I ended up making that HDA for this particular project because, in the Firewatch tower for the game, it's mostly wood planks, and so this stuff is used constantly throughout all the props and stuff like that for this particular style. All right, so let's move on to the next step. Okay, really quickly, I just wanted to show the fix for this offset. So you'll notice that these guys are becoming detached from the main legs there. And if I were to actually look at the copy node here, we're getting this unequal grid. And that's just because I forgot to copy this particular parameter. So I'm just going to right click here and say copy parameter and paste the relative reference. And now we get the perfect grid. That's what I want. I want this to be square constantly. All right, so that's that. Let's keep moving forward, and let's get our cross beams in, and let's also get rid of this bottom cross beams. I don't want those. Usually the bottoms don't have the cross beams on them. And honestly, if they do, I'm going to remove these guys anyways because that's the look I'm going for. All right, so let's move on to the next step. And it looks like the default now, because I had already set it in here, and I promoted it to the HDA, so the default is set to max. So just need to center that up. That looks good. So let's put this guy back to max. There we go. So let's change that. Let's make sure that it is just set to the default. So let's go back to our type properties. And for all these guys, we're going to set it to center. So let's just copy this one. Go to justify. Yeah. So just make sure that's all centered out for the defaults. Cool. So now we got this guy going. There we go. So now we got all those things. Let's make sure that we get rid of, the first point also over here. So you basically want to blast away primitive 0 here as well. So I'm just going to do a blast for this guy. We'll just blast away point 0, or primitive 0, sorry. Yeah. There we go. Beautiful. So we got our tower. Pretty easy stuff. You know, you just have to kind of work through how to use the point numbers and the primitive numbers, you know, for a lot of this stuff. Let's set this back to max. There we go. So now we're all perfect. And I'm going to make this a little bit smaller. Definitely a little bit thinner there. Yeah, so you guys can play around with it. I think that's looking pretty good though so far. And it's still pretty speedy. And we have UVs for everything. So pretty cool. So I'm going to leave you guys there and move on to the next step, which is building out the stairs. So now we need to focus on building the stairs that allow you to get to the top house of the Firewatch Tower. Alright, so let's start focusing on the stairs. And before we dive into constructing the stairs, let's get a little bit more organized here. So what I'm going to do is I'm actually going to select all these guys, and I'm just going to hit Shift-C on the keyboard to create a subnet out of these. I like doing this because it keeps everything kind of organized. So I'm going to say build main tower, and then for this guy over here, we're just going to do a Shift-C again, and we're going to call this build cross beams, like so. Alright, so that keeps it nice and organized. Alright, so now we got all that organized. Let's go and start focusing on building out the stair graph here. And so what we can do is we can actually build off of what we have right here. We have basically the spinning grid, right? So all the point numbers are being rotated 90 degrees for each one of those copies. And so we can just take another add node. So I'm just going to pull off over here like so, and just do our delete geometry, keep points. We'll switch over to using the by group tab, and the group is going to be skip every nth point, but remember we need to do it to every nth or every fourth point basically. And so we're just going to use that endpoints. So we're going to get the number of points that are in our grid node. Alright, so say grid 1, like so. And I forgot the P there. There we go. Cool. So then we get our spiraling curves. Beautiful. So at this point, I want to be able to give the user the ability to pick which curve to use. So we're just going to drop down a blast node. This allows us to blast away geometry we don't want. So we can default it to 0. All right, and we'll say delete non-selected, and that will leave us with one curve. So basically what we're doing there is, remember, each one of these curves is a primitive, right? So we're selecting one of those guys. So in this case, we're just going to start with 0. All right. Cool. So we should probably promote that to our HDA. And again, we can go and pop open our type properties by coming up to the breadcrumbs up here and right-clicking, saying type properties. Now let's start organizing these things. All right, so I usually start out with these simple tabs here. I'm going to call this main tower, like so. I usually, when I say I usually start, I start with the simple tab type, and then I'll change it out once I get closer to the final HDA. Cool, so I'm going to hit apply, and let's drop out another folder here. I'm going to call this our stairs. Yeah, seems good for now. We'll set this to a simple as well. And what I want to do is I want to actually create, so I need the ability to change this particular value right here on that blast node. So I'm going to drag out a integer from our parameter list over here, and we're going to say this is a range 0 to 3, right? And so where am I getting those numbers? Because remember, we have 4 primitives, but it starts at 0. So 0, 1, 2, 3, right? So we want to clamp this to 0 to 3 because for this particular system, we're only ever going to have those 4 curves to select from. All right, so this is going to be the stair curve ID. We'll call this stair curve ID, like so. Hit apply. So now I can just copy this from my HDA parameters, right? This is why I like to do this format here where I split left and right and then pin it, because I can always access my HDA parameters from this guy right here. And so now we can go to our blast node and we can just paste this like so. right? And it takes care of the proper format. So in this case, it needed a 2 backticks because really this group is a string, right? And so we have to convert it to a string using the 2 backticks and the CHS. All right, so now if I were to use my curve, you can see I'm selecting which curve to use for the stairs. All right, so just more options for the user, which is always what they want, more options. Cool. All right, so now that we've got that all set up, let's go and create our normals here. So we're going to go and drop down a polyframe node, another useful HDA that you could make, because we do this quite often. So polyframe, and then I want to create my actual directions. We're going to need the actual directions for this. So this polyframe node is creating our flow normals for us right here. And actually, now that I see this, we actually need to break it up because I don't want these particular normals to be the average direction there. So if you remember, we can drop down a carve node here, and we'll just break it at all internal U breakpoints. There you go. So now you can see the difference, right? We're getting the perfect 90-degree turns there for our normals. Beautiful. All right, so to create the other direction, so we need our right and our up directions. We'll call this curveders. Like so, we need a wrangle node, and in that wrangle node, we need to develop the actual vectors. So I'm going to create a new vector variable called flat norm. If you've seen any of my other videos, you've probably seen me do this quite a few times. Another thing you can do inside of Houdini here is save out these presets. So I'm going to set my flat norm to, or the y-axis to 0, so it's a flat normal. All right, and we can verify that if we set n, so at n to flat norm. You can see now all these guys are flat. Let me actually increase the size of my normals. So I just hit D on the keyboard with my mouse cursor over the scene view here. If we go to our guides, you can actually pull this up so you can see your normals better. I'm just going to leave it at a unit size of 1, or just unit size. There we go. So you can see now they're all flat, right? And that's going to come in handy when we actually go to create the stairs itself. Beautiful. All right, so like I was saying before, you can actually save out these code snippets, basically. If you just come up here, you can save it as a preset, right? So once I finish all the code, I'll save this as a preset just to show you guys. Oh, you're not having to type it, the same thing over and over and over again. All right, let's get rid of this line right here. And let's actually normalize. So I'm going to say flat norm is equal to normalize. There you go. We're going to normalize that flat norm just so it's a length of 1. There you go. Very cool. And then finally, we need to develop the right direction. So we're going to say v at right, and that basically declares a variable or an attribute on each point, right? So we'll get an extra attribute down here. And we're going to say that's equal to the cross product of our up, or world up, so 0, 1, 0, and our flat norm, like so. So you can see now we have that attribute right here on our points. So if you don't have the geometry spreadsheet, just hit this little plus button right here, go to new pane tab type, and go to inspectors and geometry spreadsheet. There you go. That'll be available for you. And then finally we need to do our up vector. So let's do v at up is equal to the cross product of at n. So the current normal, which is the normal that you're seeing on the screen there. Let me comment that out. So that's the normal you're seeing. Cool. And we want to cross that with the right vector that we just created. So we say at right. That'll get us our actual up vector. Now, you might want to visualize these things. So what you can do is you can select this attribute wrangle node here and hit X on the keyboard, and that'll generate a visualize node for you. And in this visualize node, we can come into the visualizers and visualize any attribute that we have on those points, right? So in this case, we just created these right and up attributes. So I want to visualize those. So I'm going to type in right for the attribute that we want to visualize. And I'm going to set this to a class of point, because remember, we put it on the points. And then finally, for the type, I want to set this to a marker. And the style is going to be a vector. So now you can see we have our right vectors. So if I turn off my normals, these are the vectors that we created with our vex code. All right, so then if we go and switch this over to up, we now have perfect up vectors. How cool is that? All right, so now we've got all the code developed. Like I was saying, let's go and save this as a preset. So I'm going to say save preset. I'm going to call this my curveder, like so, and it's going to be put into our user preference file in your documents. So wherever Houdini documents folder is, it's going to be saved into that preference file. So I'm going to say save preset. So now if I were to drop down another wrangle node over here, like so, I can just call it up by going to my preset down here, curveder. So now I've got all that stuff going again. You can verify that by plugging that into that visualize node, and there you go. So just save some time, right? So you don't have to type the code over and over and over again. Cool. So now we've got those curveders. Let's move on and keep creating the rest of the stairs. So let's focus on actually creating the stair steps themselves first here. I think that'll be a good next step for this process. So I'm going to drop down a resample node, and this basically is going to become the value that controls how many steps we have. So I want this to be an actual artist-driven number. So I'm going to set that to maximum segments there, and resample by polygon edge. So basically we'll have a stair set for each one of these guys here. All right. Cool. So what we also need to do is we need to basically create the width of the whole staircase itself. And so because we have that right director vector set up that we created up here, let's just pump that in there and use that value now to peek the position of each point. So we're going to say at p plus equals v at right, like so. And look at that. We actually have a control over that. So you can set up an amount, right? So I'm just going to say times CHF, and we'll call this stair width. How about that? There we go. And we'll just expose it by hitting the spare parameter button right here. All right, so now we have control over how much that peak is. Cool, so we just basically made our own peak. Now you could always use a peak node as well, right? You just have to transfer, because the peak node works on normals, you have to transfer the normal over, or the right vector over to the normal. So basically what you would do is something like this. You just say that at n is equal to v at right, right? And then if you look at your normals, now all of your normals are basically set to that right vector. So then you could use the peak node if you wanted to, or you could just do it all in one wrangle node, right? So that's the usual thing with Houdini. You can always do things in multiple ways. All right, so I tend to just stick with the wrangle nodes, but that requires that you just become a little bit more comfortable with the Vex code. Awesome. So now let's merge this stuff together. So we have both these guys. There we go. Beautiful. And then what I'm going to do is skin this. So what we can do with the skin node, let's drop down a skin node and take a look at this here. So I'm going to feed these guys in, and right off the bat, you're going to get a mess, right? It's just going to create a mess. But just like the add node, we have the ability to skip a certain amount of primitives, right? And this works exactly the way the add node works. If you take a look at your primnums, right? So basically, we want to skip every so many primitives here, right? And these are numbered in a very logical way. So you can see it's 0, 1, 2, 3, 4, 5. Right? So if we skip every third point here, let's test this out over here. So let's set this to skip every nth point, and we go to 3, you can see that we get perfect geometry for our stairs, or geometry that we can use to generate our stairs. All right, so that's kind of the science behind all that. It's just based off of those primnums, okay? There's no magic or anything like that. But to make it purely procedural, we want to basically come up and get the number of primitives from this resample node. So you can see it's 3 primitives, 0 to 2. All right. So there's another expression for that. Let's do this inside of the skin node. We're going to say n prims, and we want to get it from that resample node. So get the number of primitives from this node right here, right? And that will just constantly make it so it's procedural. So this can change on the fly. All right. Cool. All right, so now we've got that set up. We're pretty close to actually generating the stairs here. All we really need to do is drop down a for each primitive. So I'm going to loop through each one of these primitives here. So we're just going to loop through each one and perform the same operation over and over and over again. All right, so let's hook this up here and take a look at what we're going to do. All right, so I'm going to set this to single pass just so we can focus on a single primitive, so we can focus on what the operation is that we're going to perform. So the first thing I want to do here is I want to turn this into a stair step. All right, so how do we do that? So the first thing, at least that I did, and there's many ways you could do this, but one way to do it is the way that I'm going to show you here. So I just dropped down a transform node and set the scale to 0 and Y. All right, that flattens it out. But really, I want to flatten that out based off of its highest position here, right? And so to do that, we need to change where the pivot is. So if I select this transform node and hit enter on the keyboard, you can see that it's actually centered up in the world. All right, so that's where everything is going to happen. So if I were to transform this, right, it's going to transform from that world center. So I need to get that pivot point so it's sitting right on top of the highest most point of this piece of geometry. And to do that, it's quite simple. We just need to change the pivot translate here. And I'm going to use the $CEX, $CEY, and the $CEZ. All right, that stands for the centroid of this particular piece of geometry. Okay, so let's hit enter. You can see now we actually have it at the center. And I actually think I'm going to keep it there. If you wanted to do the highest point, since I was talking about that earlier, you just do $Y max. And now you're at the highest point. So now you can hit 0 on the scale, and it would go up to the highest point, right? If I were to do it on the center, so let's do CEZ, or CEY, excuse me. So you can see now it's centered up. So I'm just going to stick with that for now. Cool. All right, so the next thing I want to do is an add node, because I really just need the side curves. So I'm going to turn this into a bunch of curves here. So I'm going to say delete geometry, but keep the points. All right, go to polygons. Again, use our by group tab, and we're going to do groups of nth points. And in this case, 2. And that works because this is always going to be a square or a rectangle, right? Cool. So with that done, I can actually use a carve node, and I can get the center of that to build another curve down the middle. So if I just set the first U on this carve node to 0.5, right, because this is a normalized value from 0 to 1 over the length of the curve. So it's 0 to 1, right? So I do 0.5, that's the center of that curve. And we just want to extract that center. I don't need to have the leftovers here. So I just need to set this to extract. Now I have 2 points right down the middle of that particular piece of geometry. And then we can actually use another add node here. So if I drop down add node, and we could turn that into a curve. Boom, just like that. Beautiful. And with that done, we can actually utilize our wood plank HDA to build a wood plank, right? So let's just get our wood plank here, and that's going to be in digital assets. We should actually change where that goes. So let's do that now. I'm going to allow editing of contents. Let's go type properties. And that's going to be found in your interactive tab in the type properties up here. So if you go to interactive shelf tools and you go to the context tab, you can specify where you want that to go. So I'm going to put this into an IndiePixel folder, and we're going to call this the Firewatch and utilities. There we go. So let's actually copy that too and update the main HDA here. And I'm going to hit accept. And we're just going to feed that guy into there. And all we need to do now is actually change some of our default sizes. So let's change the X amount here till we get something like that. And it would be nice if I actually knew the proper size and Y there for that guy to work. And let's add a couple more pieces of or segments there. Cool. So before we go into any farther here, let's go into the type properties here and change its interactive tab submenu path as well. So I'm just going to plop that down, and this one's just going to be in Firewatch. So this is the actual object level HDA that I'm changing. Hit apply and accept. There we go. All right, so now if we were to plug this in and turn off our single pass, we have stairs for everything. Very cool. And I think I am just going to leave it on 2. There we go. Beautiful. But like I was saying earlier, it'd be nice to retain that size that we got from this add node over here. And we can do that actually quite simply by using a measure node. So let's drop down a measure node over here, and we'll plug that guy in like so. And what I want to do is get the perimeter. The perimeter will give me the length of these guys. All right, so it's 0.23. All right, and we can utilize an expression to get that value. All right, so in this case, I'm just going to get it from primitive 0. So on this particular node, we're going to look at primitive 0, and we're going to look at what its perimeter is, and that's 0.230301. So to do that in an expression, we just say prim, okay, and then open up parentheses there, and we'll type in the node that we want to get the data from. And so in this case, it's that measure 1 node. And then we want to do a float, and this is going to be the primitive number that we want to get it from. All right, and then we want to get perimeter, and we want to get the first value. So now, if I were to left click, you can see that it's that same value. How cool is that? So now we have the perfect value for our stairs. So always a way to get the values out. So let's give it a little bit of a bevel as well, just so it catches some specular. And there we go. So now we have some stairs. Or at least it's the beginning of stairs. We actually need to add quite a few more components to this. Stairs can be quite complex when it comes to all the other things like railings and platforms. In this case, the next step I want to do is take care of these platforms. All right, so let's take a look at that. Okay, so let's start with the platforms over here. I'm basically going to do this same step here. So let's actually call this our custom peak, like so. And let's just make a copy of it. So I'm just going to do Alt, left click, and drag. Hold down Y on the keyboard to bring up my little scissor tool and cut that wire there. And let's feed in this guy. So this is the starting curve that has all the curve directions on it. Let's feed that into our custom peak, and that will peak it out the same exact amount there. All right, so let's actually copy this parameter, so that way if it does in fact change, this will change as well. So let's paste it over here. Very cool. Cool, so now we have this guy going, and let's do a merge node, and let's merge the originals and the new guys that are peaked. So that way we have our width for our stairs. And then finally, what we need to do is we need to skin this. So we have some geometry, and then I want to loop through each one of the particular primitives here. And so let's set this to our skip every nth primitive, and let's just copy this expression from the other one that we did. There we go. So now we have 3 primitives, and specifically I am using this particular technique because I don't need all the resampled points, right? And so I just want solid primitives for this, so that I can loop through it. So we can do a for each primitive over here, and we can loop through each one of those guys and do a specific operation to create the platform at the top of each one of those particular stair steps there. So let's first do an add node, and this will allow me to convert this into curves. So let's delete the geometry, go to polygons by group, and I'm going to set this to skip every nth point, and that'll give me 2 curves at the very end. And the nice thing about this is they're ordered primitives, so I can get just the top one there. So it'll always be 1, 0, 1. Again, that's why I'm not resampling this particular version over here. You can remember we resampled it so we get all the stair steps. All right, so I'm just going to blast away primitive 0 there, and that will leave me with the top curve up here. And so what I can do now is I can drop down another wrangle node over here. And remember, we have normals on these that actually follow the direction of the curve. So let's write a little bit of vex code here to create a normal to allow us to peak this particular line out a certain amount, right? So we're going to say at n dot y. So I'm going to take the y-axis and just zero it out. And that basically will flatten it out, okay? And let's wire it in so we can watch all these operations happen. So we flattened out the normal, right? So that's what happens when you flatten out the y. We need to normalize it, because right now it's not a value between 0 or not a value of 1. So we're going to say normalize. And we want to pass in at n, like so. There we go. We also want to negate that as well, because we want to peek in that opposite direction that the stairs are traveling. And I want to say at p plus equals at n. There we go. And then we can merge those two guys back together. So let's drop down a merge node here. So now we have the two curves that we can just skin back together, right? So now we got those guys going perfectly. So let's feed that into the for each unblock there. Just organize this a little bit better. And turn off our single pass. Now we've got the platforms for all of our stairs. Let's merge it together just to see how we're coming along here. So I'm going to select both these guys, hold down Alt on the keyboard, left click and drag to create a merge node. So we can take a look at our handiwork. So now we're starting to create those stairs. Very cool. Alright, so with that, we're now ready. We have enough data now that we've generated to generate all of the railing and stuff like that. So let's do that now. Alright, so let's go and generate those the railing for the stairs now, which is relatively simple. Some cool techniques in here though. So let's merge together these primitives that we have here. Alright, so let's merge that in with our platforms that we just created, like so. So we have perfect stair-stepped primitives. Let's fuse those guys back together. So it's one piece of geometry now. There we go. Looks like we need to reverse our platform, so let's drop down a reverse node here. And that reverses those normals there, so now everything's facing in the same direction. Very nice. Alright, so let's do a poly extrude here, and this will actually generate the outside curves for me. So I'm just going to lift this up by like something really small, 0.1. That's enough just to give us a little bit of a extrusion there. And now I just want to also expose the front boundary group. So this front boundary group's seam is that actual edge group here. So you can see that it actually produces for us kind of the outline of all of our stairs here, which is perfect. So let's go and blast that away. And not blend shapes, let's do a blast node. Like so. And let's blast away the extrude front seam, which leaves me with just the back. So now I have these perfect curves that fit my staircase. Pretty cool. Alright, so with that done, now what I need to do is I need to get just the outside, because I'm just going to put railing on just the outside for this particular model. Alright, to do that, I'm going to utilize some grouping techniques, so let's dive into that. I'm going to create a sphere. And essentially what I need to do is I need to group all the inner points. And I know where all those inner points are because we have this initial curve up here, right here, right? Let me actually turn off the template flag. So we have this initial curve, so I can actually copy spheres to all this. So let's do that. First, I'm going to set this to polygon, and I'm just going to make it frequency of 1 and a scale of 0.1, so it's kind of tiny there. And let's drop down an object merge node. And the reason why I want an object merge node is because I want to get the geometry that's coming out of this particular node. So I'm just going to drag and drop it into this object 1 up here and turn the transform to none because we're not importing any transform information. And now I have access to it down here, right? So it just makes it easier. You could, drag a wire all the way down there. I just don't like doing that. Okay, so let's drop down a copy to points node, and let's copy a sphere to each one of those points on that curve. Perfect. So now I can use these spheres as a bounding mesh to group all the inner points of this curve here. All right, so let's do that. Let's do a group node, like so. And I'm going to select both these guys and just wire those in like so. And I'm going to name this group inner, like so. And I'm going to set it to points. And we're going to utilize the keep in bounding regions here. So I'm going to enable that one. And we're going to utilize the geometry coming in from the second input. So you can see now we are grouping our, and it doesn't look like it's actually showing up. Oh, there it is showing up over here. So one of them's grouped. Yep, that one's grouped. So they're just not being highlighted. That is odd. You know, I've noticed this in Houdini or at least Houdini 18.5, there is a bug with the display. It doesn't constantly update. That is weird. So it is selecting those two guys. And yep, it's showing that we have a couple groups there, or 2 points grouped. Why aren't you guys being selected? Oh, it looks like I have. Oh, you know why? We need to fuse this up here. You can see we have multiple points, so let me just point this out to you guys here really quick. So yeah, we have multiple points here. So we just need to fuse that, or could fuse it, or you could just do it from this point right here. There we go. So that's probably a better option rather than create more nodes. I try to stay as efficient as possible, so I'm just going to use that node in the object merge node. So that's the reason why I was doing that. There we go. So now we should have every group or every point grouped. Yeah, perfect. Cool. So now we've got those points grouped there. All right. So I'm going to promote this to primitives now. So let's do a group promote like so. So group promote, and we're going to promote inner to primitives. So we're going to go from points, right? Currently we're in a point group. We're going to go from points to primitives, and that will basically isolate that guy out like so. And that's pretty much what we need. But what I really need to do is I actually need to also select this guy, because I'm really just looking for the outer curve here. And I've already got this guy selected. So let's try this. Let's do a blast here. I'm going to blast away 0.0 on this particular curve here. So let's do 0.0, do points. We'll copy that. Take a look at our group now. At our group promote. Yeah, there we go. So now what I can do, because I want to get just these guys, and that one was selected previously, I want to do a group expand now. So let's do a group expand. Where did you go? There you are. All right, group expand. And we're going to go and get the inner group. And if you notice, now we're selecting both those guys. So that's why I blasted away that first point, because it was already selecting this bottom one. And I really want this group expand node to do that for me. All right, so we'll call this inner. We'll just cast it to the same group name. And we'll just blast it away now. Now we have the curves that we need for our railing. Yeah, beautiful. Okay, cool. So let's go and build the railing now. And to do that, we're going to have to pull this into a single curve here. All right, and so let's go and do a polypath. So I'm going to do a polypath. There we go. So now I have a single curve, right? And you know that because of the primitive count, or primitive number. We just have one primitive now for this whole curve. And I am going to do a couple things here, but I'm going to start with the vertical railing pieces here. And so I'm going to do a resample like so. Let's make sure we have our normals all set. Yeah, we have normal center perfect as well. They look almost perfect. Let's do our top view, which is spacebar 2. It looks like they're getting a little wonky. We'll see if it actually matters at all here down the line. So let's do a resample, and we're going to resample by polygon edge. So we need to select that guy, and we're going to do a length of 1. Seems good for now. Yeah, looks right to me. Cool. All right, so let's do an add node. And honestly, we don't really need to do an add node in this case, but I'm going to do it anyways, just so we end up with just points. So we just have points now. There we go. So I'm going to copy a line to all this stuff. So let's copy a line, and this line is going to be vertical. It's actually all set up for us. Yep. So 3 feet sounds good for a starting value. So we'll say copy to points. So we'll copy a line to all these guys. There we go. And it looks like we need to set our up vector as well. So let's do that right here. So I'm just going to drop down a wrangle node. And we'll say v add up is equal to 0, 1, 0. There we go. And that didn't work for everything, which is odd. So let's do something here really quickly. Let's do an attribute delete. And let's just delete the incoming normal, since we really don't need it anymore at this point. There we go, yeah. So there was a little bit of an override there. And it's just because the copy to points, I'll try to explain this as best I can, is copying a bunch of, default values that Houdini is usually looking for. Right, so there it is. So it's looking for up. Right, so I was getting a little confused there. All right, cool. So now we are all set. We can utilize our wood plank HDA. So let's go to Firewatch Utilities, wood plank. There we go. And we'll just feed that in. And as usual, just change the size here to something a little bit more realistic. That looks pretty good. I think the resampling's fine. We don't need to adjust any of the sizing or the placement. We don't need any of the normal stuff. We do need UVs. Let's add a little bit of a bevel to this here. Let me zoom in on one of these guys here. There we go, just a little bit. Yeah, all right, so now we've got all of the railings set up, which is great. So I can just template this guy so we can take a look at how this is coming along. Yeah, so we've got our railing all set up perfectly. All right, so let's go and do the bottom beams. So for the bottom beams, we actually need to get the inner curve as well. So we need to provide that up here. So where are we blasting away that inner curve? There we are. Right, so we need to get this curve. So let's do a blast up here. And we'll do inner, but then we'll just say delete non-selected, which leaves us, if I turn off our template here. So now I've got both the inner and outer curves here. There we go. That's what I need for the actual railing there. All right, so I'm going to put down a null node. This is going to be called out inner curve because we might need it for other things as well. And then let's move this guy off to the side. So this is the stuff making all those vertical beams. So let's go and merge together our inner curve. And also we need to make sure that we polypath our inner curve over here as well. So we just have a single primitive. Yeah. Cool. And we'll just feed that inner curve into here. And then we will just we'll get our up vector. We'll see if we need to delete the incoming normal. And then let's go and copy our wood plank HDA over here. See how this is coming along. It's looking pretty good, but yeah, it looks like some of these guys. Let's start by deleting our normal. So I'm just going to copy this node right here. It has that already set up. And it is spinning a little bit over here. Let's see if we can actually take care of it with one of these guys. No. We could always cut it. It looks like one of them is working fine. For the most part, it's working. It's just on this guy right here. Well, I will look into that here in just a second. I just want to keep moving forward here. So let's go and I'm going to make this guy just a little bit bigger here. Yeah, and it looks like we are getting, and that's all based off those normals. So you just have to find the right normals for all that stuff. There we go. I'll fix it here in just a sec. All right, cool. So now we got those two guys all set up. So I'm just going to select these two, merge them together. So we've got our vertical and our beams. Let's make this guy a little bit thicker so these guys aren't poking out there. Yeah, looks pretty good. And then we can merge it together with our actual stairs up here. So let me select all this stuff up here and just move it over. And we can drop down another merge node. So let's copy this, cut those lines. Yeah, so now we're making progress. So really the last thing that we need up here is the top railing. I mean, you could go and add a lot more stuff in here, but let's get that top railing in there. All right, and so to do that, all I need to do is get the outer curve. So let's do that. So this guy right here. And we just need to transform it up one. So I'm going to transform it up one, or the length of this particular line, because this is the actual vertical line. So if I copy this guy and paste it here, it'll be moved up the same exact amount as the height of our vertical beams there. And then all I need is my up vector, and then another one of these wood planks HDAs. Yeah, and we'll change the size of this guy. So it's a little bit flatter, maybe a little bit wider, like so. We'll merge that together. There we go. Now we have the stairs. All right, so I'm going to keep working on that a little bit, and then I'll be right back and I'll show you guys what I did. All right, so what I ended up doing for the inner curve here was I actually just converted it back to individual segments, and that took care of that spinning artifact that we were seeing there. It's not totally ideal. In this case it works because basically for the model these particular beams are basically bolted or nailed to the main vertical supports on the tower, so that totally works out. So that's what I did there. For the stretching, you're still going to get a little bit of stretching in there, but what I did was if I dive in here really quick, is I just increased the max stretch, and I forgot to actually save it, to 100. And that takes care of trying to retain as much as it can. It's still not perfect though, and I think it's a bug on side effects part, but not totally sure about that. It should just maintain its volume it's trying. But anyways, there we go. So now we've got that all hooked up. Everything is gold in there. So we have all those parts and pieces. So let's bundle this up now, because we have quite a few nodes there, into a subnetwork. So I'm just going to select all of these nodes here, holding down Shift on the keyboard. And then I'm going to do a Shift C, and that will put it all into a subnet to keep nice and organized. So we'll call this build stairs. And we'll merge it into this final guy, and I'm going to add a normal node at the bottom here. There we go. So I'm going to show you guys what to do about this inset right here. This first video about the Firewatch Tower is all about just showing you the tips and tricks. One thing I want to do is take care of that offset, and I also want to build an HDA that allows us to build kind of wood planks for these platforms rather than it just being a single polygon like that. All right, but that is how the Firewatch Tower works. So I'm going to close out the video there, and in the next couple of videos what I'm going to do is we're going to build the house. We're going to talk about texturing and UVs, and then we'll probably do a polish video, and I'll polish up some of those things that I just mentioned. Okay, thanks so much. I really want to thank all the patrons who have supported me over the last year since I've started the Patreon page. I really can't do it without you guys. You really do keep me going with all of my videos. I really appreciate all the feedback that you guys give. You've really helped make IndiePixel much better moving forward, and so keep sending me your video requests. Please let me know if there's anything that I'm missing. If you guys need more help with Houdini or Unity or any other topic that I'm not covering, I'll try to get to it as best I can. So thanks so much, guys. Really appreciate it.